we've discussed what has been given. Let's discuss what we know. We know that sine theta is opposite divided by hypotenuse. Hopefully that's been drilled in. If we have a adjacent line, we have an opposite line, and we have a hypotenuse line, the largest of them all, assuming that this is 90 degrees in here, and we have an angle that we can describe as this angle in there, then if that is theta, if this in here is theta, this sine function represents the relationship between theta, opposite, and hypotenuse. And I'm just going to keep repeating that. I know many of you that have perhaps watched more than one of these videos might feel very comfortable with that, or just generally feel quite comfortable with that. But I just want to drill it in that this is a representation of the relationship between OH and the angle in here, theta. And it is the relationship between these three such that you keep a right angle triangle, so that this stays right angle. Now, if I wanted to find the angle, this is considering what the angle is. If I give you an angle, it will output the relationship between opposite and hypotenuse. But I can do the opposite. I could instead be given the two sides, O and H. Let's say that this is 1 and 2, and I want to find out what the theta is, say for example 30 degrees. So let's simplify that. We're going to simplify that down. Rather than calling it theta, I'm just going to call it an angle. And rather than calling it O over H, I'm just going to describe it as the relationships between the lengths. I'm just going to call it the lengths. So sine to the minus 1 lengths equals an angle. And that's quite important to keep in mind when dealing with these sine to the minus 1 situations. It's sine to the minus 1. Whatever is in the brackets is the lengths, and it's equal to an angle. Now, let's compare it to the problem. There is our sine to the minus 1. It's staring us in the face like, yo. It's staring us in the face. We've got sine to the minus 1 there. We've got sine to the minus 1 here. So this is representing the lengths. The x-axis is representing the relationship between the lengths. And so that's what's happening. Right? That's what's happening here. In other words, actually I don't need to go into too much detail, but it would be something like as you go further and further along the x-axis, the value of O over H gets bigger. So in other words, the size of O relative to H gets bigger, because as H gets bigger, this relationship gets smaller. But generally speaking, that's what this x-axis is now representing. It is the length. The y-axis is representing the angle, and that's not too strange when you consider that we've labeled it in that manner from the beginning. The angle is equivalent to y. Now let's take a look at that. Well, notice the y value at B is 4 pi. And what is 4 pi? 4 pi, considering pi is 180 degrees, is literally a description of the length, the angle of 180 times pi, times 4, sorry. So it's 180 degrees times 2 times 3 times 4. It is the angle. So for example, let's drive this home. Imagine this is halfway, then that would be 2 pi. So that's 360 degrees. So if we put some non-radian-esque values in here, perhaps that might aid in us discussion. That would be 360 degrees. And so let's say, what about this length in here? Let's say that's half again. Then this would just be pi, right? So this would be 180 degrees. And if I went in there half again, it would be 90 degrees. So this y-axis is angles, and the angles are going up. So up here would perhaps be 8 pi. 4 rotations. And so that's what the x-axis, the y-axis is. The y-axis is the angle, and the x-axis is the relationship between the opposite and hypotenuse getting larger as you go to the right. So what have I said here? I said the number 8 represents a stretch by multiplication of 8. We can include this in our discussion. So rather than just calling it sine to the power minus 1 length equals an angle, I'm going to call it 8 sine to the power minus 1 length equals the angle. I've had to change an angle to the angle so that it's multiply both sides by 8, otherwise it would be a little bit too uncouth. But the idea here is that 8's not going to make much difference to the concept of know that the y-axis is an angle and know that the x-axis represents the lengths if we are discussing it in terms of this. Sine theta is opposite over hypotenuse. Okay, let's add a little bit more information before we move on to the next video, and that is what we can say therefore. We can say that therefore the length is equal to x minus 3 over 2. All I've done is I've said, well, let's pick a different color and illustrate this connection. If in there is what we described as the length, then there must be the equivalent. x minus 3 over 2. These two are brethren, right? That is what is being, those are the lengths. So I can just say they're equal. I say, okay, therefore the length is x minus 3 over 2, and the y is the angle. And when I say lengths, again, let's not forget, I mean opposite divided by hypotenuse, the length of opposite divided by the length of hypotenuse there. And so we're going to utilize this information. The most important concept is that the angle is the y, which is what I've just described in here, and this x minus 3 over 2 represents the relationship between them. We don't need to know in detail how they're linked, because this is just x minus 3 over 2. That'd be quite a complicated conversation. But we now know what is occurring, what this represents, hopefully. And now let's tackle the problem given some basic trigonometry and some algebra for which I judge we can do.